Okay. So hi everybody. My name is Karandeep Kawatra, and I'm part of the machine learning. I'm also part of the machine learning pathway, and today I'm going to be walking through what we did, what we accomplished over the past 6 to 8 weeks in the summer internship. So today what I'm going to be talking about is I'm going to be walking through the steps of how we web scraped. Then I'm going to be going over like how we pre-process the data just so we can like read our results. We can analyze it. Then I'm going to explain how we approach our 3 approaches to our model. I won't go too much deeper into like how it works, rather like what we got and what this means. And then I'm gonna like show you a glimpse of like our final like deployment, or like how the product actually looks like towards the end of the project. So this project is known as a tag annotation tool, and this is with the active learning loop, which I will explain further on. But first, I want to kind of define the project for you, just so I can explain like our issue. So initially, what we saw on the STEMaway forum, if you haven't been on there yet, you should check it out. And if you're planning to be an intern, so initially, what's happening is that we're in some of the posts in the forums, we have some tags that are missing. Like on the top over here, half of the posts that you see on the STEMaway forum are not tagged. And now you might be asking yourself, why is this a big problem? Well, because tags actually help people look through the forum and help them like navigate through the website, the platform much more easier. So initially, each post either has like 0 tags, some have like 1 tag, some like every other post has like a tag or 2. But what we essentially want is we want a post with multiple tags. Like on the bottom over here, you can see we want a tag that has multiple desired level of tagging. We want like multiple tags at once, and our goal is just to build a prototype that could do just that. And we want a model that can predict over 70% of the time the correct number of tags based on what the user wants the people to see. So so before I get too much into before I get started with the actual tag recommendation engine, I have a question for all of you guys. So if you guys can type in the chat or the Q&A feature or whatever, I want you guys to drop some names for any websites, applications, or anything you use that involves tagging of some sort. Where have you seen tags applied? Like where have you seen like tagging in general? I just want to see. Can they type in the chat?
Yep, I think they're already getting some responses.
Okay, let me take a look. Reddit, YouTube, yeah, those are good ones, definitely. Social media for sure. It's a big platform for using tags, definitely. Quora, Quora has a lot of tags like that. I tried scraping it once from Quora. Those tags are really complex. It's really like hard to look through. But yeah, you guys are all right. You guys are all correct. Basically the websites you guys listed, those also involve tagging to an extent. So essentially how this model essentially works, don't be intimidated by this architecture. I'll kind of like explain a little bit step by step. So first, how this model works is a user is going to first start off with creating a comment or a post on the STEMaway forum. And what happens next is that the comments will be split up as what we call a test data. And this data is going to go into the model right over here. And we're going to try to match with the training data, which is the data we're going to feed the model so that it is able to predict. And from here, we've actually built a model, which I'm going to further elaborate on later on. And this predicts a certain number of tags that you want. So let's say if you want to predict 10 tags, the predictor you're gonna ask like how many tags you want. You can say 10. It'll predict the tags. And once the predicted tags have been displayed after the user's comment, the user actually gets to choose which tags he wants to put into his post. And how this is done, we used a tag annotator tool There's many out there, but we use one called Prodigy. If you don't know what Prodigy is, I didn't know it myself either. Don't worry about it. You'll learn it. You will learn it later on if you decide to pursue machine learning. But how this essentially works is that a user can select any number of tags he wants to post on the forum. And then after this, what happens is the user's post itself, as soon as he posts, this data would essentially be stored into intermediary data set. And how this works is we use what's called an active learning loop, which sends the data set back into the model. And this could, and I'll kind of explain later on why this is actually useful and why we actually kind of stored this data back into the model. So I'm gonna get started with walking through the steps of how we did it. So, I keep forgetting. Yeah, there we go. So how we started was we web scraped. You guys can learn about web scraping in the machine learning pathway hubs, but essentially what we chose to web scrape the Stack Exchange forum. And why we chose to scrape the Stack Exchange forum, because Stack Exchange actually gives us a publicly available online database, and it has a lot of labeled tags over here that's corresponding to multiple posts. And we're trying to see essentially the behavior of the tags labeled to the post on the Stack Exchange and see if this behavior matches with any other forums, like our StemAway forum, for instance. And you can see over here, there's like the votes. These votes kind of help us to ensure that this post is like credible. And so that way we know that the right number of tags are associated with based on the content and the title of the post. So how we essentially approached it, and if I can summarize the steps, what we did. So we collected all the titles of the posts, all the content, and all the associated tags. So essentially we took this and we took the tags that are mainly focused on machine learning, artificial intelligence, CS, computational science. We kind of took all the tags that are related to this pathway. If we web scrape the whole Stack Exchange forum, that would have probably blew up my computer, or that would have taken ages. And we then stored this data into a CSV file, and we separated these into 3 columns, title, content, and tags. And then we performed our EDA, which I'm going to go through in the next slide. Yeah, so our EDA is essentially, Yeah, so essentially what we found here is that this is what we call a class imbalance problem. And this is the reason why is because we can see there's like the bars really high for one tag over the other tag. So I know if it's kind of small for you guys, the most common tag that was mostly predicted was machine learning. And machine learning was like the most frequent tag, most likely tag that was able to be predicted. And this one of the challenges we faced when trying to implement our model is that when we try to run our model, machine learning was always the tag that machine learning or deep learning was like the only tags that were always predicted. And it didn't really give much value to the other tags lower on the bottom. And essentially it just kept predicting the same tags over and over again. And that became kind of an issue for us. But then what I personally did myself is I took all the tags and made the unique tags. And you can see in the number here, it's about 1,120 tags. I took those are the unique tags. Essentially what this means is the unique means not repeated. It's just like one time, like all different tags. And essentially what this bar graph shows is that around each post on average, there's about 3, 4, or 5 tags that are tagged on this post. And this is actually what we want, because this is one of the reasons why we chose Stack Exchange, because it gives us a good number of posts, or a good number of tags that we can take and put it into our StemAway forum. And so we can give like a right number of tags. And okay, so this is a multi-label prediction approach, and this is what we call a multi-label classification. Don't worry too much about all the vocabulary and the formulas over here. I'm going to kind of explain it in a little bit simpler so it can make sense. Multi-label classification it's a type of classification which we predict a lot of tags, a lot of labels simultaneously. So like over here, I included an example of all the tags that are that we have in like our dictionary. And then the topic here is which is better, machine learning or deep learning for classification. And so we use these 3 metric scores, precision, recall, and F1. I'm not going to go, you guys have already learned it in the beginning. I'm not going to go too much into depth, but essentially the simple answer for precision scores is that these tags are not supposed to be there, but they're actually predicted there. And so I have a question for you guys. Which tags do you think are the tags that are simply not supposed to be there? Like the tags that are that the precision would penalize. Can anybody take a guess on the chat? Like which tags? So up here we have the actual tags, and then up here and then down here we have the predicted number of tags. So we have 4 of them. Can anybody guess which tag would precision penalize? There's 2 actually. Let's see. Good job. Yeah, that's exactly right, Shrav. Yeah, that's it. Clustering statistic. Yeah, those are the tags that precision will essentially penalize here. And then the next metric score is kind of the opposite. Well, not really. You can kind of think of it that way, but it's called the recall score. And wait, here's add the animation here. Yeah. So the recall score essentially is that it penalizes the tags that should have been predicted, but it didn't predict. So can anybody identify which tag was supposed to be predicted, but was not actually predicted? Like it was supposed to be there. Can anybody identify for me in the chat? Good. Yes, you guys are both correct. Deep learning. Yeah, so deep learning was a tag that's supposed to be there in our model, but is not actually there. So recall is gonna penalize our model for that. So yeah, here's the animation. And then F1 score is kind of, you guys can think of it as like the mean. Now this mean, be careful, this mean is not the arithmetic mean. This is what we call a harmonic mean. And this mean is calculated essentially a little bit differently than your average high school, what you learn in your high school stats class. So it penalizes the precision and the recall score at the same time. And this is one of the things I would recommend more. It's kind of like a combination of like precision, recall, and F1. We didn't use accuracy score, and the reason why is because accuracy score kind of like it doesn't take into account the true positives, false positives, and all that good stuff. And if you don't know what that is, don't worry. You can learn it later on once you join the machine learning pathway. Okay, so our very first approach we tried was what we called the Bur model. And the Bur model was essentially, we kind of explained a little bit in the beginning, but it's just the probability. Okay, yeah, so I'm gonna go quickly into this. So basically what the pros of using the Bur model is that it gives us a contextual embedding. And one of the cons is that the estimates of the Bur features in training the neural network is very time consuming. And Bur only has about 768 features, and it doesn't give us a lot of space to work with because we have a very big data set, and Bur has like about 768 features to train with. And it was very hard to get into our active learning loop and get over about a 70% accuracy, which is one of the problem statements we defined. And our next approach was the TF-IDF model but this one was with a neural network. And what the neural network essentially is that the embeddings, these TF-IDF embeddings are much faster than Bur. They work much quicker. They can work on bigger data sets. But essentially, the only problem is if you give too many features, it's going to take a long time to process those results, sometimes usually. And over here, I included kind of a snippet of like how the code works if you're interested in like coding and all that good stuff. Logistic regression is this is the one we actually ended up using because it's much faster to train, and they don't always fit the data. And yeah, so these regression models you can train with like any type of data set. And over here we got about a 90% accuracy score for the F1 score, and that actually worked out for us really well because it was one of the models that actually fit our data perfectly. So we kind of went with this model, and I'm gonna go quickly into the active learning loop. In the next slide, hold on. Yeah. So essentially how the active learning loop works is that the users can predict the top 10 tags for their posts. They can select that they want. And the data tags that are given by the user, they add to the data set for further active learning. So essentially what the benefits of the active learning loop is was once the user selects the tags, users post and tags annotated. The active learning loop can help us repeat the process multiple times so that we could keep running this model and it could keep working. And essentially the more times we run the model, the test data will get implemented into the loop, and it will help us predict a better accuracy, and it'll help predict tags much better. So for all of you visual learners, I'm going to show you guys how this works a little bit. So if you guys didn't understand like what I was talking about for the past 5 minutes, I'm going to show you how this works. So you type a text number, right? And then let's say you type the title. And then you essentially type in like your question. Like if you're on like a forum, you have a question about, you don't know about machine learning, you type a question in. And then after this, the model is going to send you like 5 or 10 tags to predict. And you get to choose which tags you want to put. So you're like, ooh, maybe neural network. I'm gonna select those. Select multiple one of these, and then you post it, and then the process works. It sends back to the active learning loop, goes back into the model. So yeah, all that good stuff. So how is this going to actually, now you might be asking, how is this going to be useful in the real world application? This is going to be useful for STEMOA interns, maybe you, maybe me, the panelists, all of us over here. It's going to help you. It's going to help us navigate the website much more quickly and much more efficiently when each post is tagged versus the posts that are not tagged. So we want to essentially put multiple tags onto one post so that it can help the user, if it can help interns find the resources, find the messages from the team leads, any important like internship opportunity, or not internship opportunities, any opportunities, job opportunities that they have. So one of our further expansion goals is to expand this to all the pathways. Also, we want to make sure this helps not only machine learners, but bioinformatics, full stack, all the other pathways out. And this can help increase efficiency into helping interns navigate through STEMOA. And that's all I have for you guys. If you guys have any questions, drop it in the Q&A.